Hi guys, welcome back to the searching module. In this video, let's try to learn about the last searching algorithm that we will be concentrating in this specific module, that is interpolation searching algorithm. Okay, interpolation searching algorithm is exactly similar to binary searching algorithm but with a small change. But before we go and learn about interpolation searching algorithm, let me just give you a brief overview of what binary search is so that you will be all also on the same page. So in the case of binary search, we are given an array of values. In this array, we have some number of values, right? And based on the size of the array, we have the start index and end index. And based on these two values, we calculated the middle position. Based on this middle position, we either searched on the left part of the array or on the right part of the array based on the nature of the value that we have in the middle index. Okay, this is the binary searching algorithm. How we calculated middle? We will simply calculate it middle with start plus end divided by 2, which gave us middle index value. Okay, so interpolation searching algorithm is also exactly similar, in which we will have the starting part of the array and ending part of the array, and obviously interpolation searching algorithm also requires the array to be sorted completely, either in the ascending order or in the descending order. Once we have such kind of array, right, in interpolation searching algorithm, what we do is we calculate what we have mid for binary search. We will calculate a variable called position in the interpolation search. So the formula for calculating this position value is basically start index plus end index minus start index divided by whatever the value we have at the end index minus whatever the value we have at the start index. Okay, whatever the result we get here, right, that result we will multiply it with whatever this whole result that we get, we will multiply it with value that user has passed for searching minus the value at the start index. Okay, this is basically the formula that we use for calculating the position, using which we either search on the left part of the array or on the right part of the array based on the value that user has passed and based on the value that we have at this position in the array. Okay, the algorithm is very simple. It is exactly like binary searching algorithm. In case of binary searching algorithm, we divide the array into two parts based on the middle index that we calculate. Similarly, in the interpolation searching algorithm, we exclude the remaining part of the array based on a value called position, and the formula for calculating position is something that you can see on the screen. Okay, let me just explain the same thing using a simple example so that we will be clear. Here we have the array containing these values. So it has totally 7 values in it. Okay, the starting index is at 0 and ending index is 6. Okay, when we learned about binary searching algorithm, I represented the start with min value and end with the max value. Okay, it is just the nomenclature difference. However you want, you can represent it according to your convenience. Okay, once we have these two values, right, what we need to do, we need to calculate the position using this formula. Okay, so let me calculate, and along with this, let's assume that the value that user wants to search is 11. Okay, so the value that user passed is 11. Okay, now what we will do, we will first calculate the position according to the formula we have here. So here the value for position will be, right now the start is at 0. Okay, and end is at index 6 minus start is 0 divided by the value we have at the end index, that is 76 minus the value we have at the start index, which is minus 71. So that minus and minus will become plus, so the value will be this. Along with this result, whatever the result we get, we multiply this result with whatever the value that user has passed, that is 11 minus array of start. Array of start has a value of minus 71. So minus into minus will give us plus 71. Okay, if we calculate this value, it will be something like 6 divided by 76 plus 71 is 147. This multiplied with 82. Okay, let me just open the calculator and see what is the result we are going to get here. So 6 divided by 147, the result is this one. We need to multiply this result with 82. So into 82, which we will get, we got 3.34. This will give us 3.34 something. Since it is a floating point number, we will floor it to get the value as 3. So as part of the calculation, the position that we have got is 3. So at index 3, this is the position value we have got. At index 3, we have the value 19. Okay, the value that we have here is 19, but the value that user wants is 11. So obviously 11 is smaller than 19, right? And the main constraint for interpolation searching algorithm is the array needs to be sorted, which is ascending order here. So what we need to do, since the value we need to search is smaller than the value we have in the middle, which is 19 here, that means it will be on the left part of the array. So what we will do, we will again search in the left part of the array by moving the end to position -1, that is nothing but end. Now end will be located at 2. Okay. Similarly, if the value that user has passed is not 11, let's say he wants to search value 57. In that case, since the value is on the right side, right, that means the possible search range for the value that user has passed is on the right side of the position index. So similar to binary search, what we will do in that case, we will update the start to position +1. So the search range will become from index 4 to 6. But in the example that we have here, the user given value is 11, right? So the end will become position -1, that is 2. Again, we will calculate the same one. So still the start is at 0, end is at 2 minus start is at 0. This divided by array of end. Array of end is 2. We have a value of 11. 11 minus array of start is -71. So plus 71 it will become. This result we will multiply with whatever the value 11 minus whatever the start value we have here, which is -71. So it will become +71. So if we get this result, it is 2 divided by 82 into 82. So we will get this 82 will get cancelled. We will get the index 2. Okay. So if we go and search the index 2 here, so the position that value now we have got is this one. Okay. Whatever the end index is there, that itself, based on the calculation of the position using the formula we have got here, we got the index 2. Now what we will do, we will go and search the value at the position. Okay, the value at the position is 11. Okay, so the value that user has passed and the value that is at the index position is matching. So in the case of binary search, this value is nothing but middle, right? So in that case, we will simply return the middle index. Here, since it is matched, we will simply return the position index. So we will simply return 2 as output to the user, whoever has implemented this function. Okay, I hope you understood the algorithm behind it. It is exactly similar to binary searching algorithm. In the case of binary searching algorithm, we divided the array into left part and right part based on the middle index. But in the case of interpolation searching algorithm, we need to calculate the position. That position can be calculated using this formula. Okay, that's all there is. Now that we have understood the algorithm behind interpolation search, let's try to write the pseudocode for it. Okay, so in this case, we will write a function called interpolation search. It will take the array and the value that user wants to search. Okay, when we get started, what we will do, we will define a variable called start. Okay, we will initialize it with 0. Along with this, we will also define one variable called value. This we will initialize it with length of array -1, because this is the last index in the array. Okay, along with this, we will also define one variable called position, and we will assign -1 to it. Later on, when we actually iterate over the array and calculate the position, we will update the position with that specific value. Okay, in the case of binary searching algorithm, what exactly we did, we ran the logic as long as the start is less than or equal to end, right? Similarly here also we will do the same thing. While start is less than or equal to end, along with that we will also do whatever the range that we are checking, that should be the possible range for the value that user has passed. That means since the array is sorted in ascending order, right? So whatever the range, let's assume that the range that we are searching is this one, okay? And the value that we are searching is, let's say, 12 now. But if I want to search 12 in these three elements, 12 is not there. So we can simply eliminate the searching, right? How will we eliminate that is basically whatever the value that user has passed, if it is greater than equal to whatever the value we have here. That means ARR of start along with this, whatever the value that I'm searching should be less than or equal to the largest value we have in the range. That is, value is less than or equal to ARR of end. Okay, as long as this condition is matched, we will calculate the position using the formula that I had explained here. Okay, I will not be writing the formula once again here. Once this position is calculated, what we need to do in the case of binary searching algorithm, we compare the value at this position. Okay, if it is matching with the value of the value that is passed by the user, we will simply return position. Okay, if it is not the case, else, that means whatever the value we have at position, that is array of position, if it is greater than the value that user has passed, that means the position value is greater than the value that user wants. That means the left part of the array could contain the value that user has shared. So we need to move the end index to position -1 so that we can search it in the remaining part of the array. To do so, we will simply update the end index with position -1. Okay, so just remember that this position and this position all are same. It's just that, just to write it in a simple terms, I'm just putting it in the words and writing the shorthand nomenclatures here. If this is not the case, that means whatever the value we have in the position is, whatever the value that user has passed is greater than the value that we have in the position. That means it is on the right part of the array. So we will simply update the start to position +1. Okay, this is how we actually run the logic. This logic will handle the case when we have the value that user passed in some part of the array. In that case, we will return the position. But what if the value is not available? In that case, we need to return -1. Okay, this is the simple pseudocode that we write for implementing the interpolation searching algorithm. Okay, I hope you understood it. In the next video, we will be writing the implementation for it using the respective programming language. Okay, thanks for watching. I'll see you in the next one.